Hi everyone, my name is ChaseBernauer. I have 5 audience members joining me on Zoom. Would you all mind saying hi or simply waving at the camera? Okay, let's get started. Imagine learning how to design a bridge without ever building one, or programming a robot without ever testing it. That's exactly what many engineering students face in programs that focus only on theory. This leaves future engineers underprepared for real world challenges. As an engineering student myself, I've seen the gap between lectures and reality. That's why today I want to persuade you that engineering programs should include more hands on project based courses. This approach helps students understand the material better, stay engaged, and develop career ready skills. And as I'll show you, there's research and real world success behind this method. Before we dive in, I brought something with me. This basic tool set. It may seem simple, but it's a great example of what engineering students actually need. Not just theories, but tools and opportunities to build, test, and problem solve. When students apply concepts to real projects, abstract theories become clearer. The American Society for Engineering Education found students in project based environments perform significantly better on assessments. In my own experience, building a prototype water pump taught me more about fluid dynamics than an entire semester of lectures and exams. According to a 2006 study in the Journal of Engineering Education, inductive teaching methods like project based learning improve both comprehension and retention compared to traditional lectures. Hands on experiences allow students to make mistakes and learn from them. This trial and error process is where deep learning occurs. Without it, students may understand the formulas but fail to apply them under pressure and in real world scenarios. Even simple physical activities like creating cardboard models or wiring basic circuits can deepen a student's grasp of abstract concepts. These moments help connect classroom theory with real world application. Project based learning keeps students active and interested. A Purdue University study found that hands on learners reported higher motivation and classroom satisfaction. You're more likely to care about what you're learning when you're actually building or designing something. Plus, it brings out leadership and teamwork skills that are often overlooked in lecture halls. A study published in the International Journal of Engineering Education found that students involved in project based courses were more confident in solving open ended problems, which is a major part of engineering work. One of my favorite projects involved designing and 3D printing a mechanical clamp. It wasn't perfect, but it pushed me to think critically and solve real design issues that you don't necessarily run into when you're in lectures. I stayed up late researching new mechanisms, not because I had to, but because I wanted to. I was interested in what we were doing. Hands on projects create a sense of ownership. When students are responsible for outcomes, they take pride in their work, become more invested in the material, and often exceed expectations. Employers want engineers who can think on their feet, communicate ideas, and lead teams. Project based courses help develop these skills far better than exams can. The National Association of Colleges and Employers reports that students with practical experience and project portfolios have a higher chance of being hired. According to a review on CDIO educational models, project based learning models like CDIO have shown success in schools like MIT, preparing students for real world innovation. Beyond technical ability, these experiences build communication, leadership, and time management skills. They're often the experiences that stand out in job interviews and on resumes that employers like to see. Project based work encourages collaboration. You might work with students from computer science, business, or design. These interactions mirror real engineering teams and build a broader understanding of how projects actually get done in the real world. The Accreditation Board for Engineering and Technology also supports experimental learning, stating that the students must be able to demonstrate design capabilities and teamwork by graduation time. Additionally, universities that use project based learning often see higher retention rates in engineering majors. That means students are not just learning more, they're staying committed to their studies and wanting to learn more. We've seen that project based learning improves understanding, boosts motivation, and prepares students for their careers. As future engineers, educators, or decision makers, we should advocate for education that reflects the realities of the workplace. Students need room to experiment and fail. That's where growth happens. Trial and error teaches perseverance, creative problem solving, and flexibility. These are the traits real engineers rely on, not just memorizing equations. Imagine you're hiring someone to design a bridge. Would you pick the person who aced the test or the one who actually built a working model and refined it based on performance testing? Employers ask the exact same questions. Companies like Google, Tesla, and Lockheed Martin aren't just looking for a good GPA, they want portfolios. When students graduate with real project experience, they can say, here's what I built, here's how I think, here's how I work on a team. Research from Stanford also shows that hands on, iterative design work helps students retain knowledge longer and build resilience through feedback and iteration. Even in high school and early college, programs like Project Lead the Way and First Robotics are setting the standard for hands on learning. These students often outperform their peers when transitioning to university level engineering coursework. To sum it up, engineering isn't just about equations, it's about solving real problems, and students can't do that effectively without hands on practice. The visual aid I brought, a simple tool set, is something we often overlook, but it represents what's missing in many classrooms. Students should be allowed to tinker, assemble, and design as they learn. Physical tools foster mental tools. And if we want to start building a better future, we need to start by building better engineers, and that starts with giving them the tools, the space, and the freedom to learn by doing. Thank you.